Jump past question 2001. Question number 33. When a piece of rectangular glass block is inserted between two parallel plate capacitor at constant plate area and distance of separation, the capacitance of the capacitor will A. increase, B. decrease, C. decrease then increase, D. remains constant. The question today is centered on capacitance of a capacitor. The capacitance of a capacitor. In electricity, there are two circuit components at this secondary school level that stores electrical energy. These circuit components are a capacitor and an inductor. Both store electrical energy, but in different ways. A capacitor will store electrical energy in electric field, whereas an inductor stores electrical energy in magnetic field. However, this question is centered on capacitance of a capacitor. If the capacitance of a capacitor will increase, certain factors must be observed. So the question is somehow linking the theory to an equation that we will expose with time. There are factors that will improve the amount of electrical charges stored in a capacitor. And those factors are, to make it simple, let's see those factors in capacitor's circuit symbol. This is a capacitor circuit symbol. A capacitor must have two parallel plates. They must be parallel and equal. Two parallel plates. Let's label A and B. They must be parallel and equal. When you have this, it's no more a capacitor. This circuit symbol is a cell. A cell has parallel plates that are unequal. One is longer than the other. The longest one is positive and the shortest one is negative. Whereas in a capacitor, the parallel plates must be even. Okay, secondly, a capacitor must have distance of separation or a gap in between the parallel plates. Okay, let's call that D. Then lastly, a capacitor should have an insulator in between the parallel plates. For the capacitance of a capacitor to increase, these are the conditions. Number one, the larger the surface area of the parallel plates, the bigger the capacitance. Let's take that mathematically. Capacitance is directly proportional to area of the parallel plates. The higher the capacitance, the higher the area. So increasing the area of the parallel plates will increase our capacitance. More charges will be stored. The area provides space for the charges to be accommodated. Okay, larger area, bigger capacitance. Then the smaller the gap, the higher the capacitance. This is direct proportion, A and C. C and D, indirect proportion. The smaller the gap, the bigger the capacitance. When the plates are too close, then we have more storage. That's what the point entails. Okay, then there should be an insulator in between the parallel plates. We call the insulator dielectric substance. Dielectric substance or material. A dielectric substance or material must be an insulator. There's a reason for that. Recall, a capacitor is a storage, it's like a reservoir. In a plumbing system, it's like the tank. For this capacitor to store charges within this tiny space, there should be an insulator and not a conductor. If you have a conductor there, the charges will flow and pass through. The charges will pass through the space and continue flowing in the circuit. But we want to store the charges here. Therefore, we need something to damp the charges. And that's an insulator. So our dielectric substance must be an insulator. And when you have an insulator, you are increasing the capacitance compared to when you have a vacuum. Some capacitors have vacuum here, but you cannot compare the capacitance there if everything is kept constant. Like the question made clear. The parallel plates, the area is constant, and the gap of separation is constant. If you now have a capacitor with a vacuum, empty space, and a capacitor with a piece of rectangular glass block, which is an insulator, then what happens to the capacitor? It's very simple. The capacitance of the capacitor will increase. Where you have a vacuum, charges will come and flow and pass because charges flow better in a vacuum compared to an insulator. A vacuum is like a conductor. So the best option there is having an insulator. Example, rectangular glass block within the power plates, so as to damp the electrical charges and to get them stored within that space. Then finally, we'll find a way to involve this idea in the equation. Then our formula will now become capacitance is equal to permittivity of a material. If you have a vacuum, we call permittivity of free space. But this is now permittivity of a material times area all over distance of separation. In summary, the higher the area, the higher the capacitance. When you have an insulator, the higher the capacitance. Then the smaller the gap between the power plates, the higher the capacitance. You can see that most theoretical questions target a particular physics equation as exposed now. Please stay tuned as we push ahead. So the best option there is that the capacitance of that capacitor that has involved an insulator, which is rectangular blocks within the power plate and no more a vacuum, will do what? Increase. Thank you. Stay tuned as we push ahead.